Welcome back. In this lesson, I'll set up a serial console on the Raspberry Pi so that I can log into the Pi even when it won't boot or connect to the network. So I set up a serial console. Remember in the last lesson where I had a display connected to the Pi's HDMI port? It showed a bunch of messages as the Pi booted. Those boot messages are sent to what's known as a console, and they're really useful for seeing what's gone wrong if the Pi doesn't boot properly. If you don't have a screen attached, you won't see those console messages, so you'll have no idea what's gone wrong. And if the Pi doesn't boot to the point where the network comes up, or your Wi-Fi is down or something, you won't be able to log in from the network. And if you don't have a screen or keyboard attached, you're stuck. A serial console displays those boot messages, so you can see if something's failed, then it lets you log in and fix the problem. So I consider it essential for embedded development of the Raspberry Pi. So essential that I designed it into the Wombat prototyping board, so you can use any ordinary micro USB cable as a serial console, but we'll get to that in a minute. The Raspberry Pi has a serial UART, which in case you're interested, stands for Universal Asynchronous Receiver Transmitter, which can be set up as a serial console, and it's brought out to the 40-pin GPIO connector, where you can connect to it. Pin 8 is transmit, pin 10 is receive, and remember that's transmit and receive from the Pi's point of view. They share a common ground, which can be any of the numerous ground pins, but pin 6 is the most convenient because it's right next to transmit and receive. Like all of the GPIO pins, the UART pins are 3.3 volts. If you put 5 volts into them, you'll fry them, and RS-232 voltage levels are definitely out of the question. So to connect to them, you need a USB to serial cable that operates at 3.3 volts. They're often called FTDI cables because FTDI became famous for USB to serial chips. They're very well supported, but there are other manufacturers such as Prolific that are cheaper and work okay, although the drivers for them can be a bit problematic. They're sometimes called TTL serial cables. You have to be careful there because strictly speaking, TTL is 5 volts, and 5 volts is no good for your Pi at all. Just connect the receive pin to transmit, the transmit pin to receive, and ground to ground. Or, if you're lucky enough to have one of my Wombat prototyping boards, which has a genuine FTDI chip on board, simply close the transmit and receive jumpers to connect the USB serial through to the Pi's UART pins. If you also close the USB power jumper, you can power the Pi from your computer's USB port, as long as it can supply enough current, which is generally the case. Use the supplied ribbon cable to connect the Wombat board to your Pi's GPIO pins. Then plug an ordinary micro USB cable from your computer to the Wombat board. With one USB port acting as a serial console and supplying power, and with Wi-Fi set up on the Pi, you don't need any other connections, just what you see here. It's a really convenient solution. Okay, now the Pi's serial pins are connected to your computer, we need to tell the Pi to go ahead and use those pins as a serial console. So I'll log into the Pi, as we did in the last lesson, and then run raspberry config again. The serial port is an interface, so I'll go to Interfacing Options. That's what I'm looking for. Kernel messages on the serial port, so I can see the Pi booting, and Shell, so I can log in via the serial console if things go bad. So yes please, OK, and back out again. Now if you're wondering what that did, it updated a couple of files in /boot. Config.txt, as you might expect, specifies various hardware configuration options. The enable UART equals 1 line at the end enables the UART. And on a Pi 3, it also locks the CPU frequency, so the serial communications will be reliable, something that's not necessary on earlier models. Command-line.txt specifies parameters that are passed to the Linux kernel, including what to use as a console. Serial 0 is the UART associated with the serial pins we're connected to. Under the hood, the actual UART depends on whether you're using a Pi 2 or 3, but everything's set up correctly on each model by default. What's important to note here is the 115200, which is the baud rate the serial console is being set to. You can change it if you need to, but with the USB serial connection, there's no need to. Now I'll reboot, so that these changes can take effect. Let's try that again, remembering to use sudo this time. OK, the network connection drops. So I'll close this SSH window and then go open a serial terminal. But first, I'll have to find out what COM port the USB serial has been mapped to. Since I'm using Windows, I'll open the device manager and look at the COM ports. I've got a couple, COM3 and COM6. And unfortunately for me, they're both FTDI chips. I think one's my oscilloscope. I could unplug the Pi to see which one disappears, but there are only a couple, so it's not going to be a problem to try one, then the other. Now I can fire up PuTTY. And I'll try COM3 first, setting the speed to the baud rate we noted before, 115/200. Actually, I'll try COM6 first, since I plugged in the Pi most recently. Give the new serial session a name, save it, and open it. We have a login prompt on the serial console. I can go ahead and log in as usual. The W command tells me where I'm logged in, on TTYS0, which is serial port 0, exactly as it should be. I'll just make this window a bit bigger, so you can see more of the console messages. Then you can see what happens when I reboot again. Now, instead of just losing the network connection and not being able to see what's going on, we can see all the shutdown messages, then watch as the Pi boots again. Much more entertaining, isn't it? Now that the Pi is back up, I can open an SSH session again, over the Wi-Fi to the Raspberry Pi. But it's not working. No login prompt. Why? Turns out that the Pi was allocated a new IP address when it rebooted. That's the sort of thing that can happen. Luckily, one of the boot messages on the serial console just happens to be the current IP address. Pretty handy, eh? Now I can update my PuTTY session with that new IP address and try connecting again. Since it's a new IP address, PuTTY gives me the usual security alert, but I know it's the Pi, so I trust the new address. Then I can log in over SSH as usual. And that changed IP address is a good illustration of how a serial console can be useful. That's all for now. Next time, we'll do a bit of basic digital input and output with the Pi's GPIO pins. See you then.